let us see what happens when y has to do with 1 in terms of mathematical operations. Notice 4 mathematical operations here that are basic: addition, subtraction, multiplication, and division. The first is y plus 1. When this y is added to 1, is there a reason to tell what the answer will be? Please, what do you think it is going to be? Since this y is not known and 1 is added to it, you cannot tell what the answer will be. That means that y and 1, when added, will not give us any simpler answer that will make us have a simpler expression for them. Therefore, there is no other way to express this y plus 1 apart from y plus 1. If this y is something like 100 and you say 100 plus 1, you cannot come here and write 101. If this y is 50 and you now say 50 plus 1, we can comfortably come here and say that the answer is 51. But since y is not a constant, y is a variable, if you add 1 to a number, you cannot tell what the answer will be. Therefore, it remains y plus 1. When you cannot reduce this to a simpler expression, let us say that that expression is irreducible. Let me write it down. And here it comes. Y plus 1 remains y plus 1. We then say that it is irreducible. What about the next one? Subtracting 1 from y. Like the other one, if we know what y is, we can subtract 1 from it and tell the simpler answer. But because y is not a constant, it is a variable, we cannot tell a simpler way of writing the result of y minus 1 except y minus 1. So the answer to this expression is still y minus 1. So what again am I going to write here? The same thing. The answer is again what? Again, the answer is irreducible. What about this y times 1? Y times 1. It means any number times 1. Any number times 1. Let us use some examples to show what the answer could be. Now look at these examples. 5 times 1. What is it? 5. Do you doubt it? If you bring 1 into 5, the result is equal to 5. 7 times 1 is still equal to 7. 10 times 1 is equal to 10. What if we don't know what we're multiplying? We understand here that any number at all that multiplies 1 is equal to that same number. See 5 multiplying 1, the answer is still the same 5. See 7 multiplying 1, the answer still became the same 7. See 10 multiplying 1, the answer is still the same 10. So whenever any number multiplies 1, the answer is equal to 1. So what am I going to write here? Okay, just watch out. Yes, the answer is equal to y. I hope that is not difficult to conclude. Based on this numerical experiment, we conclude that any number of any type in any form times 1 is equal to that same number. The last one says y over 1. If you say y over 1, it means 1 dividing y. Please, when 1 divides y, what will the answer be? In like manner, let us do some experiments with numbers. So afterwards, we come back and tell what the answer to this operation is. And here come the experiments. 8 divided by 1, that is when 1 divides 8. This will just mean let one person divide 8 things. If one person is to divide 8 things, please, how many will that person get? He gets the same 8. I hope that is clear. When one person divides 12 things, the person will still get a 12 because no other person is dividing with him. So he takes everything. Also, when one person divides -9, what is the answer? They say -9. We therefore conclude that whenever 1 divides a number, the result is that same number. Whenever 1 divides anything, that anything is now this y. When 1 divides anything, the result is that anything. So what is going to be here as a result? Okay, please, again, watch out for the answer. Like before, the result is equal to y. Please make a record of these results. 2 are reducible. y2 are reducible. This and this reduces to y, while the first two could not take a simpler form. Like I said before, please take note of these outcomes. We just finished with this y with 1. What about y with 0? Let us look at arithmetic operations of y with 0. And that is it. We are now going to consider y with 0. The first is adding 0 to a number. Y plus 0 is the case in point. When 0 is added to a number like this y unknown to us, is there a reason to produce something simpler? Yes. Don't forget the meaning of this 0. 0 means nothing. In accounting, it means I have nothing, I am owing nobody. At least it means I have nothing. So when you bring nothing to something, what is the answer? Logically, the answer is something. You are bringing nothing to join with something. In the end of the exercise, you have done nothing, except that the former thing stands out. You have not produced any change in the value of that thing you added 0 to. Therefore, when you bring nothing and add it to something, what is the answer going to be? Even without experiment, we can tell that the answer to this is going to be equal to y. Let me write y here. So 0 plus y is equal to y. That is it. 0 plus y is equal to y. What about the next one? Y minus 0. Subtract 0 from something. It means removing nothing from something. If you remove nothing from something, you have not done anything to that something. That something remains unchanged. So if that something is y and you subtract 0 from it, what would the answer be? The answer is going to be equal to what? Please watch out. And here it comes. The answer is still equal to y. I hope you agree with me that the answer to the first is y and the second is still y. The third one, y times 0. Y times 0. Let me carry out a simple experiment before we give an answer to this one. Let y represent any number at all. Let a number at all multiply 0. Let us see what the answer will be. Please watch out. And these are some selected experiments. We have this 5 times 0. The answer is 0. Why? 5 times 0 means bring 0, 0, 0 into 5 times. If you bring nothing into 5 times, you have brought nothing. Now, 20 times 0 is also equal to 0. It means bring 0, 0, 0 into 20 times. That is, bring nothing into 20. If you do that, you have still brought nothing. The same thing is applicable to 9 times 0. The answer will also be equal to 0. Since we have 5 here, we have 20, we have 9. It means that these numbers can vary. Call them variables. Let y stand for all variables. So y times 0 at all times is equal to what? If the answer is going to be equal to 0. Let me write it. And that is it. This is y times 0 is equal to 0. And that is taking us to number 4, 0 over y. Don't forget that the number below is that divides the one on top. So here, it is not this that divides this, but it is y dividing 0. If you set 0 over y, it means something dividing nothing. Something dividing nothing. Let me, in like manner, carry out a few experiments before we come back and give the answer to this. Remember, something is dividing nothing. As long as this y is not 0. Even if it is 0, the answer remains the same thing. Please, let us see some experiments. Just 3 of them. Simple like that. When 2 persons divide nothing, each person will get nothing. When 100 persons divide nothing, each person will get nothing. That is correct enough. When 7 persons divide nothing, each person will get nothing. Therefore, when some persons, that is y, divide nothing, no matter how many there are, the result is always going to be nothing. So what we put here, it is 0. And that is it. When y divides 0, the answer is equal to 0. Whether what is here is 0 or above 0 or just anything at all, the result is equal to 0. The fifth one is when 0 divides something. This is the inverse of this. If you watch this and watch this, they look alike, and yet they are inverse of each other. In the first case, y is dividing 0. In this case, 0 is dividing y. Are you thinking that the same answer will be here? Certainly no. Please permit me to give you just the answer and explain what the answer stands for, without explaining how the answer came to be what it is. First, let me write an answer to when 0 divides something. As long as this y is not 0, if it is 0 over 0, the answer will be equal to 0. But if y takes any other value which is not 0, and 0 divides 8, what will the answer be? Let me tell you and explain what I have said. And here it comes. When 0 divides anything which is not 0, the answer is equal to infinity. This sign that resembles 8 lying down is called infinity. What is the meaning of infinity? It is a number so large that its value is not definite. Which number will you say is the highest number in existence? You can't lay hand on anything you can call and say that number is the highest. If the number you know has a limit of billions, you will tell me that the highest value, the highest number that exists is billions. If trillion is what you know, you might think that the highest number counts in trillions. But you don't know that we still have quadrillion, we still have pentillion, we have hexillion, we have heptillion. In fact, there is no end to counting numbers. Or is there any number, a number you can think is the highest as you count? If you are told to count from 1 onwards, when will you stop and you say you have counted all existing numbers? Certainly, there is no number you will count and say that the number is the highest. It exists only in your mind. The highest possible number is so large that it exists only in your mind, but doesn't exist in the real world. Such a number that is so large and infinite is called infinity. How the answer came to infinity is beyond the scope of this lesson. In a separate presentation, I will explain how infinity came to be the answer when 0 divides a number which is not 0. It remains just one operation with 0 and we bring it to a close. What is that? That is going to be 0 minus y. Let's see what it turns out to be. And here it is. That's number 6. We have had results to 5 different operations with 0 involving y. The 6th one is 0 minus y. We are not going to interpret this as subtraction. Here, we know that this minus meant subtraction for us to get this y here. But here, this minus is not going to mean subtraction. We know that we can subtract 0 from nothing, from something, but we can't subtract something from 0. A number must exist before you start taking it away. But this 0 is nothing So how can somebody subtract something from nothing? This makes us change the way we look at this minus here. Please permit me to rewrite this in a form that is more understandable. Look at what it means. This expression, which is recast here, simply means 0 plus minus y. So this is a complete way of writing this. With this, we can begin to tell what the answer will be. Don't forget that y stands for any number which is not 0 in this case. 0 plus minus y means I have nothing, but I'm owing somebody y. Join the two of them. Again, I have nothing, that is 0, but I'm owing somebody y. Y is just any number at all. It could be 100, it could be 200, it could be anything. But it means what we are owing. This minus here is not a sign of subtraction. You can now see that from what I'm saying, it stands for owing. Minus has up to 4 meanings. The meaning it has here is not the meaning it has at this point. If you assign the same meaning to both places, you begin to get things difficult. But because of variety of meanings of minus and plus, we can always get the correct answer to number operations like this. Again, it means I have nothing, but I'm owing something. If you join both of them by means of reconciliation, what is it going to be? You have nothing to pay. So what will you do in accounting? You are owing somebody and you have nothing to pay. All you should do is take note of your liability. Therefore, I have nothing, but I'm owing somebody. So I will keep on owing the person that thing. The only time you are compelled to pay without postponement is if you have something to pay. If, for instance, you have maybe 2 here and you're owing somebody 10, you must pay with the 2 and still owe the person 8. You don't postpone payment if you have any asset at all. But in this case, there is no asset at all. Everything is liability. So what we do, we take stock of liabilities. And what then becomes the answer? I'm owing somebody y, but I have nothing. So the answer is owing somebody y. Therefore, the answer is equal to what you see shortly. And there it comes. 0 minus y is equal to minus y. I have nothing, but I'm owing y. So the answer is equal to owing y. Let us look at another case of arithmetic operations with self. Let y be engaged in a number operation with itself. That is what we do next. Please follow along.